Hello everyone, today we want to talk about a phenomena in power system with the name of missing zero crossing phenomena. So normally in power systems, when we have a fault or short circuit somewhere, for example in this line or any places, the relay detect the fault, overcome relay detect the fault, and send a trip signal to the circuit breakers. And the circuit breakers normally should de-energize the line during uh, the time that we have the zero crossing point. For example, if we open the IEEE 14 bus system, and if we see, for example, how is the uh, short circuit in one of the lines, for example, uh, I had some short circuit, I deactivate them. So for example, we can make EMT analysis. So first we can make some simulation event, short circuit event, for example, at 0.3 and okay, and here we want to see the current go through this line. For example, right click, reset variables for this line. From the EMT we just need the phase current for the line and click OK and close. So here we have the EMT analysis. So we insert a plot, curve plot, and here we have this line, variable, this, and OK. So if we run the simulation, for example, for 2 seconds, here we can see here we have the normal situation, and then we have a fault. And when we have a fault, the current will go very high. So we have a DC decay and we have the simulation sinusoidal together. So if we have a circuit breaker, normally the circuit breakers de-energize the line when we have a current and or voltage when they crossing the zero value, because then we will not have any polarity or current from two sides of this circuit breaker, and then can easily de-energize the line. And if we want to simulate that one, we have the fault here, right click, simulation event, short circuit event. Here we put clear short circuit. Here we can see at zero crossing or immediately. So we put at zero crossing. So we had fault at 0.2. So normally it takes around 300 milliseconds to detect and open the circuit breakers. So we put 0.5. Okay. Run the simulation again and see. So here the circuit breaker is opened and done. So then we have normal situation. But sometimes in some situations, I deactivate the fault here. Sometimes in some situations we have high DC decay value, then we will not have any zero crossing points. So for example, here in this line, if we change the reactance to resistance ratio, so normally it's around 6 ohm, and we reduce to 0.1 and the reactance to 25. So in this situation, we'll have a huge DC decay value. So if we have a fault, short circuit, for example, at 20% of the line, for example, and in this situation, if we see the current from this side, here we can see, we will not have any touch of uh, the zero value. So you can see that the current will go high and will not have any touch of zero crossing point or any zero crossing point until 1 second. So if we make a fault carrying event at zero crossing, for example, after I don't know, 0.6, You can see here it takes time to have any zero crossing, and then here we can have the uh, opening of the circuit breakers. If I reducing the value for fault clearing here to 0.2, for example, here we have that because we have some very small amount here. So the voltage has some zero crossing. So in the current we don't have, but in the voltage we have the zero crossing. So if I add the result variable for voltage here, phase voltage in per unit or kilovolt, for example. And here we can add different phases. Okay. So here, this is phase B. If we run the simulation again, so you can see here, always we have the zero crossing in the voltage, but in the current we don't. And for other phases, if we look, for other phases we have the zero crossing. So the circuit breaker using the zero crossing of other phases, but for phase A we don't have. So in this situation, we can have opening of the circuit breakers, but if for other phases also we don't have the we don't have any zero crossing point, then the circuit breaker cannot open the uh, the, the line. So in these situations, normally if we have the phenomena that all three phases doesn't have any zero crossing point, normally because the reason is the wrong ratio, the very high ratio of X to R. Normally we should insert one resistance with the circuit breaker to the line.